So in this video and subsequent videos, we'll be looking at sample problems relating to the stiffness of an elastic materials. So let's start by looking at the question here that we have on our screen. So the question says, what is the spring constant of the spring that needs a force of 3 Newton to be compressed from 40 centimeter to 35 centimeter? So we should take note of the following points. In the question, we were given the value of force, which we are going to represent by F, to be 3 Newton. And then we have our original length, which is represented by L1, to be equals to 40 centimeter. So we are now going to convert this 40 centimeter to meters, which will then give us 0.4 meters. So then we now have our final value of the length, which is represented by L2, to be 35 centimeter. So now we are also going to convert this to meters, which will then be equal to 0.35 meters. So these are the following parameters we have gotten from the question. So now we are now expected to find the change in length in the spring that we're gotten. So we should not forget that the spring was compressed. So the change in length will be represented by a negative sign to show that it was compressed. So let's go about solving that. So here the change in length, which will be represented by delta L, will then be equals to L2 minus L1, which is then equals to, on L2 we have 0.35, while on L1 we have 0.4. So when we do the subtraction, this will now be equals to minus 0.05 meters. So now the next thing we are now expected to do now here is to find the spring constant of the spring. So in order to do that, we are going to make use of Hooke's law, which states that force is equals to the product of the spring constant multiplied by the change in length, which is delta L here. So therefore, if I were to change the subject formula, the spring constant would then be equals to force all over delta L. So you should remember that our value of force, which is F, from the question is 3 Newton, and our value of the change in length is negative 0.05 meters, as we see here. But we should, or in this case, we are going to ignore the negative sign since we are looking for the spring constant. The spring constant here is always positive. Since it's a constant, it should be always positive. So we are going to ignore the negative. We are going to go on to add that, so which will give us 3 all over 0.05. So 3 divided by 0.05 will give us 60 Newton per meter. The Newton per meter is the SI unit in this case of the spring constant of the spring. So that's our answer, 60 Newton per meter. So if you found this video helpful, don't forget to like and subscribe and drop your questions in the comment section below. Thanks for watching and see you in our next video.